Here we have a new page. And what is written here? Terminal block and wire specification, local control cubicle. This part is also very important for us. Specification, local control, this part is also very important for us. This part, the first thing it tells you here is the details of the thermoblock. Through this, you can know what each thermoblock is associated with, like each thermoblock here, for example, XA, XD, X8, or whatever. Each thermoblock is connected to which circuits, like here it writes for you, A sub Y, D sub Y, A line disconnector, whatever. Each circuit is connected to which thermoblock. Should we memorize it? No, wait until we go inside the drone, you will see it with your own eyes. All right, and it also writes for you the type, who the maker is, and how many AWAB you have. This part is very important to me because when you come to do something in your setup, or when you start, you add something, for example, or change a circuit, or do anything here, you need to know your wire specifications. Of course, so here I explain to you what type of wire is used for what. For example, the wires used in the AC power supply. The wires used in the DC power supply. Those used, for example, in the earthing wire, in the CT circuit, in the VT circuit, and so on. Okay, for example, regarding the AC supply, in the diverse 20-volt AC supply, which is single phase, you use the terminal, which is one of the wires, the red one, which is the red, and the neutral, meaning as a phase, meaning single phase, so you use one red wire and the other black. As for the DC supply, you always find it using the gray color for all control circuits. All the control circuits, you find the wire is gray color. The circuit breaker tripping is also gray color, while the alarm circuit is blue color. Okay? All the AC circuits, as you can see, you will find their size is 2.5 millimeters, while the control circuits are all 1.5 millimeters, and the alarm is 1.5 millimeters. The circuit breaker tripping is 2.5 millimeters. And this is, of course, because the circuit breaker tripping is the most important thing for me. Therefore, the smaller the wire's cross-section area, the greater the voltage drop on it. Consequently, the voltage reaching the tripping coil of the breaker might not be sufficient to disconnect the power. That's why it is 2.5 millimeter. By the way, the circuit breaker tripping as well. It's circuits. In some stations, for example, it even reaches 4 millimeter. All right, nice. So what you have here is about the cables in addition to the cable colors. But if you come across something called additional marking, what does that mean? Look here with me. You have the wire in this shape. I also brought a picture like this. For example, I used to work with it in control circuits. All right, look guys, this is how it is. This is the shape of your rosette, for example. Of course, there are different shapes and types. And this is the ferrule. The ferrule is like a cylinder that is placed around your wire, and symbols are written on it so that it indicates where your wire is connected or where it is coming from, essentially writing an address on it. The ferrule itself, as you can see, has nice writing on it. It tells you what the red wire you see is for, but if it's specifically for an AC circuit, for example, then you have the AC circuit with a red wire and a black wire, which are the red and black, and their thickness is 2.5 millimeters. It then tells you in your drawing here, and then here in your drawing, it tells you that the wire ferrule is white and has black written on it, meaning the sleeve color is white with black writing. What does this mean? It means the ferrule that I have drawn here in yellow is actually white, and the writing on it is in black. Excellent, nice. So, what's next? All right, and then you have something else called additional marking. Of course, additional marking usually might not have anything special except for what is related to the direct trip. Concerning the circuit breaker trip, you will find something called a letter word written here, which is trip. Regarding AC, it tells you R and N. What does this mean? This means that you also have additional plastic pieces placed here, like a ferrule. These plastic pieces have R written on them, N written on them, and the letter T or the word trip written on them. So you understand that this wire is used for tripping, and this wire is used in the AC. All right, so this is something called additional marking, which means something extra that clarifies things for you more or conveys the information to you in another way. All right, not forgotten. Nice and close. So this is the topic of the wires. All right, as for the earthing wire, you'll find the earthing wire is 4 millimeters, and it's the system with the yellow and green, which is yellow in green. All right, nice. Now, why do I need them? Because if you, for example, want to add a new alarm and connect it to the annunciator or the PCU, in this case, you need to get a wire that is black. And it should be 1.5 millimeters. You must use it, and it must be 1.5 millimeters, and so on. And another important thing is the type of it. Pay attention, this type is very important. Why? Because now, for example, here in Saudi Arabia, I was working, for instance, at one of the stations in the Saudi Electricity Company stations. Why do we refer to it as an abbreviation and so on? Saudi Electricity Company and so on. Okay, so you have the table in front of you, which belongs to the Saudi Electricity Company. When you came to make modifications to the circuits, suddenly the main contractor, as we were working as a subcontractor, came to you and said, do you need anything? I said, I want to make some modifications according to the interlocking table I have. He said, no problem. Do you need anything? I said, I need a gray wire, 1.5 millimeters with the same specifications. So what did he do? He actually brought a gray wire cable, 1.5 millimeters. Great. So he brought it. The Aramco guy was with me. The Aramco witness who was receiving the work from me was there with me. We looked at the wire and said, no, this isn't it. How come? The insulation isn't the type that Aramco uses. The table here specifies a certain type of insulation, but he brought a different type of insulation. Okay, so what's the idea? The idea is that you have cables that they use. For example, they have a certain standard. They come and tell you, this cable inside my control circuit, if, God forbid, any short circuit occurs, it causes a spark. So this wire is supposed to not catch fire if a spark occurs. All right, great. So we brought a lighter, and when you try to hold it to the wire, you find that it catches fire. So its insulation is not the required insulation. It's not like when you're working with electricity at home, connecting a bulb and using any wire. No, here we are working in control circuits related to GIS, dealing with equipment worth millions and circuits where mistakes cannot happen. So you must be very careful with all the technical specifications available in your directory. Excellent, great. Okay then, regarding the CT circuits and VT circuits, you will find for the CT and VT circuits, you have the red, yellow, blue, neutral. All CT circuits must be 2.5 meters, all internally 2.5 millimeter. All VT circuits you will find are 1.5 millimeter. All CT circuits have their wire color as yellow, and all VT circuits have their color as red. The ferrule on it is white and written on it in black, and there is additional tagging like a number that says RYBN, RYBN, which stands for red, yellow, blue, neutral, red, yellow, blue, neutral. Here, I have explained to you the specifications of the wires that are inside our local control cabinet. Now let me talk to you about the wires. Between your panel and the other panel, or the control box of the breaker and the switch, here's what happens. There's a local control cubicle here, your local control cubicle. You might have wires connected to the mechanism of the GIS itself, which includes the breaker, the switch, and the grounding. So there is an interface or wiring extended between the local control cabinet and the GIS, right? Great, so here there are wires extended with the mechanism of the disconnector and the earthing switch, and there are other wires extended with the mechanism of the circuit breaker, correct? Great, so are these the only things present in the GIS? No, why? The GIS also has the CT box, and the VT box, meaning the current transformer itself, has wires coming out and connecting to your cell, and the VT has wires coming out and connecting to your cell as well, right? In addition to the SF6 gas gauges that we will see in the next slide or the next page, which are the meters that read the gas pressure of SF6. Nice? Great. So it tells you here regarding A1 and A2, which are the set of cables extended between your local control cubicle and the mechanism of the earth switchwork disconnector or the circuit breaker. It tells you, well, regarding the cable A1, which is extended, this cable is 2 core, all right, 2.5 millimeters, 2 core, 2.5 millimeters, all right, great. And then it says, well, this is 1.5 millimeters, 24 core. All right, so if you come to tell me, well, here is a 2-core cable and a 24-core cable, yes, because the 2-core cable, which is 2.5 millimeters, is definitely used for the heater, all right? So you'll know from where to follow it like this. You'll continue and you'll find, I told you, I don't know, the black cable here, I told you, in the end, it's a heater, and the 24-core cable, meaning 24 wires, all right? Where is this used? In DC, circuits. Which takes, for example, the status from the breaker and then goes to give a close command to the breaker and gives a trip command to the breaker and so on. Now, regarding the P, C, and D cables, P is the interface between my cell or my panel with the SF6 gas gauges, C with the VT circuits, and D with the CT circuits. Someone might come and say, well, the CT and VT you mentioned to me in your previous explanation, aren't they? The CT and VT, I'm talking to you about the internal wiring, meaning you are moving from one place to another within the same cell of yours. Something related to the CT circuits will use cables that are yellow with a white stripe and written on in black, and its cross-section is 2.5. However, the CT circuits that are coming to me from the GIS itself and reaching my cell, these are considered external wires, external wiring not included within my panel. In this case, what will these wires be like? If you look at the CT cable, you will find, as you can see, cables of 2.5. Okay, great. And for the C, which is the VT circuits, you will find 4mm cables. As for the gas, which is the gas gauges or the SF6 gas pressure meters, they are 1.5mm. All these cables will be 6 core. And we wrote this for the gas control, this for the VT circuit, and this for the CT circuit. Okay, nice. Now, it describes to you how the ferrule is written, the additional tagging, and all the things we are talking about. All right? Now you know the size of each wire and what circuits each wire is used for. You know, the details of each wire and its color, right? Is that correct? All right. I will connect this wire. We said, you put a ferrule on it. All right. What color is this ferrule? We said it's white. And what's written on it? It's written in black. Now let's see what it says. It tells you that you have switch 1. As you can see, whatever it is, you have a wire connected here to terminal number 64 and a wire from above connected to terminal number 63. Good. So this wire has a ferrule and that wire has a ferrule. All right, so what do I need to say about this ferrule? As I told you, this is the address of the wireless address would be. Now, what's written on this ferrule, or how is it written? Let's see, this ferrule comes from something called X1, which is the thermal block, and goes to something called S1, which is the switch. So how is the ferrule written? We said initially you hold the ferrule properly and you read it from left to right. From left to right, exactly. So if you're looking from left to right, which is considered from bottom to top, for example, now for you, you'll read it again. The thing on the left, which is written on the left, is the thing. It is connected to, and the thing on the right is the thing it is coming from. So now, here on the left, what do I write? I write S1 number 64 / coming from where? Coming from X1 number 74. So you'll find the front is marked in the way you see. Okay, the flow on the other side, which is the other direction, is going here to X1 number 75. How do I read or write the flow? You'll also find from left to right, the left is labeled S1 number 63, and the right is labeled X1 number 75, which is where it is going here below. Is that clear? So it's not necessarily that the part touching or the part close to the thing it's connected to is labeled with that thing. No, you read in the room from left to right. The left is labeled with the place where the wire is currently connected, and the right tells you the place where the wire is coming from or going to. All right, great. So what is this? This is the ferrule, exactly like what I showed you in the picture. You have this MCB, which I named F2, and this push button, which I named PB1. Is that clear? Great. So I connected a ferrule here, connecting a wire from here to where? To where? If you look at this wire, as you can see, read it from the left, you'll find it labeled F22. All right, which is what? F222, that's the place where it's connected. And on the right is the place I'm going to. Now, if I go to the other place, which is the push button itself, I'll also read from left to right. This time, on the left, I'll find the push button. Why? Because that's the place where I'm connected. And on the right, who will I find? The thing I'm coming from, which is the miniature circuit breaker. Of course, someone might say to me, so you found a push button on the left, and here on the left, you also found an MCB. I'll tell you, as I said before, it's not necessarily the case. As I mentioned, read the flow in its correct orientation. Look at how the flow is oriented. On the left, it should show you what it's currently connected to, and on the right, what it's going to. All right, great. And then you have an additional part, a small piece of flow, which is the additional marking. This additional marking is written here where it might say R trip or Reiben to let you know that this is a trip or to indicate that this is an EC and so on. As you can see, here is the cable. This is a cable, regardless of its color, whether it's yellow, gray, or blue. It has a ferrule on the left side. This ferrule is labeled with what your wire is connected to. And on the right side, it indicates where it is coming from or going to. Then you have your cap or head here, and at the end, you have your lugs or the terminal, where you connect meaning you connect it to the terminal block itself. This is what goes into the terminal block gate. Great. So the same applies if you connect it down here. Here is X1, and you have a ferrule. Look from left to right. So on the left, you'll find X14. And then here, I'm focusing on X14. And on the right, where is it going? It's going to S14, and then to S14 and Z. Great, okay.